Hello there, everybody. How are you? I hope you're doing well. This video here is going to show you, hopefully, on how to multiply two binomials. I am going to show you three methods for doing this. You can take your pick. You can try all three. Maybe you'll like one of them. Who knows? Maybe you'll like all three of them. The first method is sometimes called the area method or the area model. You make a little box and you're going to put some stuff on the sides and then multiply that stuff and write some stuff in the middle of the box and come up with your answer that way. That's the area method. I'll show you that in a second. The second method is called the double distributive, or sometimes we used to call this the FOIL method. So I'll show you how that works for multiplying two binomials. And finally, this other method I'm going to show you, I don't really have a name for it. I'm calling it the stack method, and you'll see why when we get to it. You may have never seen this one, or maybe you have. I don't know. Anyway, let's talk first about the area method, all right? The area method, or sometimes called the box method, sometimes people call it that, it's based on the very simple fact of the area of a rectangle is computed by base times height. Right? You multiply those two quantities together, those two dimensions of the box, of the rectangle together, and that's how you get the area of the rectangle. Okay, so let's say we are going to multiply two binomials like x plus 3 times x minus 10. There's your two binomials. Well, what you do in this box method is make a little box, divide it up into 4 parts, and then write those binomials on the sides of the box. Those binomials now represent the dimensions of the box, like the base and the height. So we're going to multiply base times height, essentially. But we'll do it one little box at a time. And that upper left-hand box there, x times x on one side and x on the other side, that's x squared, right? Then go to the right. So one side of that upper right-hand corner box is x, and the other side is 3. All right, like base and height are x and 3. Multiply those, and you get 3x. Lower left-hand box is a negative 10 times x, negative 10x, and the lower right-hand box is a negative 10 times 3, which is negative 30. Okay, so you got all the numbers inside the box. Now, please observe this very important fact that those two diagonal terms there, they each have an x. Those are what we call like terms, and they should be simplified down into a single term. In this case, 3 and negative 10 make negative 7x. So our answer is just x squared minus 7x minus 30. We're just literally taking all of that stuff out of the box, the simplified pair there to negative 7, and that's how we get our answer. All right, let's try another example. That's what that green line was there, is dividing up the field, and so I can work on another example here. Let's try 3x minus 2 times 2x plus 7. Okay, so there's our box with the dimensions there, 3x minus 2 on one side and 2x plus 7 on the other side. You start filling in the boxes, and that's what you get. Now, I just did that real quick here in the video, kind of to save time, but please make sure that you see where each one of those numbers came from. The 6x squared was 2x times 3x. The 21x was 7 times 3x. Etc. Okay, and once again, you're going to combine those like terms into a single term, 17x in this case, and our answer is finally 6x squared plus 17x minus 14. So that's the box method. It's a pretty good method. You can use this to multiply two binomials, or a binomial times a trinomial, or any kind of polynomial times any other kind of polynomial. It's a great way for organizing all the steps required to pull off one of these multiplication problems. Sometimes people don't like it because they don't like making boxes, or they're a little disturbed by the fact that the box has maybe, 2x on one side and 3x on the other side, but they both look the same, or negative numbers is weird to have as a dimension. So sometimes people don't like this method for other reasons. But if you're cool with all of that stuff, it's a very nice way to organize your work. All right, next method is called sometimes called double distributive method, sometimes called the FOIL method. All right, let me show you how this one works. This one, okay, we're going to take two binomials, in this case 2x plus 5 times x plus 9, and double distributive. So distributive property is when you take a number times a quantity. So like 2x times x plus 9. And what we're going to do is just multiply each part of that separately. So 2x times x is 2x squared. Write that down. And that, incidentally, is the F in FOIL. FOIL stands for first, outer, inner, last. So this would be the first terms of each binomial. Multiply those together, you get 2x squared. Now, if you do the 2x times 9, now you're doing the outer terms. The 2x and the 9 are the outer terms of our pair of binomials. That gives you 18x. The I in FOIL is the inner term, so that's 5 times x, 5x. And the L stands for last, so 5 times 9 is 45. So first, outer, inner, last. Again, you get 4 terms, and it's just a kind of a different way to arrange all the different parts of this problem. The little sub-steps, you might call them, of the problem. So again, we combine our like terms together, and we get 2x squared plus 23x plus 45 as our final answer. Okay, let's try another one. I'm going to show you something that is kind of a common problem in multiplying binomials together. This would work out, we could use any method to do this, but I'll just choose the FOIL method to demonstrate this particular situation. And the situation is squaring a binomial, x plus 5 squared. Okay, so there's a really common mistake that a lot of people make in this problem, and it is this, that x plus 5 squared equals x squared plus 25. No, it does not. It does not equal x squared plus 25. Okay, let me just take that idea out of your head right away. Hopefully you won't make that mistake too many more times, if you ever do. So what does x plus 5 squared equal? Well, it is x plus 5 times x plus 5. That's what this little exponent of 2 means. You're squaring it. You're multiplying it times itself. All right? So if you use the FOIL method to multiply those two identical binomials together, all right, x times x, you got x times 5, then you got 5 times x, then you got 5 times 5, that's first, outer, inner, last, and you add the two middle terms together, and you get x squared plus 10x plus 25 as your final answer. Notice that 10x there in the middle, that wasn't there when you just squared the x and squared the 25. There is an x squared, and there is a 25 in your answer, right? But it is not just x squared plus 25. That middle term makes all the difference in the world. Okay, on to the last method called the stack method. All right, this method is kind of interesting. It's just really just like you may have learned how to multiply two numbers. Now, if you were in elementary school and you learned a different method for multiplying two numbers than the one I'm going to do right here, this method may seem rather foreign to you. But anyway, a lot of people were taught how to multiply two numbers together, such as 23 times 61. Okay? They stack them on top of each other like that, and they just kind of go, first do the 1, so 1 times 23 is 23. And then they do the tens, 6, so that's 6 tens, 60. So then what they do is they put a little 0 in the ones column, right? And then we just multiply. 6 times 3 is 18. So you get 1380 when you multiply 60 times 23. And then we finally add our results, and our final answer is 1,403. And that's our answer. Yay. Okay, now what we're going to do is treat a pair of binomials in the same way. We're going to stack them up. So let's say we got x minus 5 times 4x plus 3. You write them on top of each other like that, just like we did with the numbers, and we just do the exact same process. 3 times negative 5 is negative 15. 3 times x is 3x. Moving down now. Now you can write a 0 there if you want. You don't actually have to, but you can write the 0 there. And 4x times negative 5 and 4x times x, you write the result there in the next row or the next line. And finally, we add our results, and we got a negative 15 and a negative 17x and a 4x squared. And voila, we are done. We've got the answer to our problem using the stack method here. Okay, well, I'm just going to do that one example on the stack method. You can take it or leave it, of course, which, you can take or leave any of these methods. Try them. See if one of them really clicks for you and you seem to like it. This method also works for multiplying a binomial times a trinomial and everything, which those are tricky, kind of messy problems sometimes. And so I highly recommend that you pick one method to organize all those steps to make sure you don't do a silly mistake. Every mathematician makes silly mistakes. So the more organized you can be to kind of reduce the possibility of making silly mistakes, the better your math is going to be, right? Okay, I hope you're well. I hope everything's going well for you right now. And let's go out there and do some math.